So we're going to do our Exam 3 in-class review in statistics. So know your vocabulary words from chapters 6, 7, 8, and 9. They're on your handout and on the videos. We're going to use the theoretical method to determine the probability of the given outcome or event and state any assumptions that you need to make. So rolling a single six-sided die and getting an even number, which would be 2, 4, or 6. Well, it's 1 out of 2. Assuming all sides of die are equally likely to be rolled, there are 6 numbers and half of them are even. Drawing a 10 from a standard deck of 52 playing cards. Well, it's 4 out of 52, which will be equal to 1 out of 13, assuming that each card is equally likely to be drawn. And because there are 4 10s in the deck of 52 cards, if I picked 5s, there'd still be 4. There are 4 of each number or each type of card in the deck. Remember, there are 4 suits, so there's 1 in each suit, and there are 13 cards in each suit. There's 2 through 10, Jack, Queen, King, and the Ace. So finding that when tossing a coin, it turns up tails, given that it has turned up tails in the previous 5 tosses. Well, that's still 1 out of 2, or 0.5, assuming that heads and tails are equally likely to occur. Each coin toss is independent of the tosses before it, and the probability is unaffected by prior information. What is the probability of randomly selecting a day of the week whose name doesn't include the letter D? Well, that's going to be 0 because every weekday has a D in it. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. They all end in day, so it's 0 out of 7, which equals 0. In each exercise, let's find the probability of the given event and state any assumptions that we use. Not drawing a queen from a standard deck of 52 playing cards. Well, the probability of not queen equals 1 minus the probability of drawing a queen, which equals 1 minus 4 out of 52. Remember, there are 4 queens in a deck of 52 cards, because there's 1 queen in each suit, and there are 4 suits. Well, that's equal to 1 minus 1 out of 13, as we reduce 4 out of 52, which will get us 12 out of 13. Remember, we're assuming a fair deck of cards where each card is equally likely to be drawn. What is the probability of randomly selecting a person and getting someone who does not have type O blood, given that 5% of the people have type O blood? Well, the probability of not type O equals 1 minus the probability of type O, which equals 1 minus 45 out of 100, which is equal to 1 minus 9 out of 20, which equals 11 out of 20. Now, I'm reducing them as we're going, but you could go ahead and get 55 out of 100 and then reduce that to 11 out of 20, either way. So, in terms of the law of large numbers, explain why you should not be surprised to see 7 heads in 10 tosses of a fair coin, but you should be surprised to see 700 heads in 1,000 tosses of the same coin. With a relatively small number of 10 tosses, the probability of getting a result slightly away from the most likely outcome of 5 is still quite high. However, when the number of tosses is 1,000, the outcomes will be tightly distributed around the most likely outcome of 500. So a result of 700 would be highly improbable. What is the gambler's fallacy? And give an example. Well, the gambler's fallacy is the mistaken belief that a streak of bad luck makes a person due for a streak of good luck, or that a streak of good luck will continue. There are many different examples, but here is one to look at. Flipping a coin lands heads 5 times. Most people will believe that the coin will land on tails the next time because it's due for a change. A job seeker sends their resume to a very large number of potential employers. What does it mean to say that the law of averages will have someone eventually hiring the job seeker? Is it true? And explain. Well, it means that the job seeker is due for being hired. If being hired for jobs happens randomly, then the statement is not true. If being hired for jobs depends on resume submissions, it may be a true statement. So a roulette wheel has 38 numbers with 18 odd numbers and 18 even numbers, as well as 0 and 00, which are green. If you bet $5 that the outcome is an odd number, the probability of losing the $5 is 20 out of 38, because that means you'd have the even numbers plus the 0 and the 00 gets you to 20. And the probability of winning $10 is 18 out of 38. So if you bet $5 that the outcome is an odd number, what is your expected value? Well, for the $5 bet, the expected value is negative $5 because you paid $5 to play, so that's minus $5 times 20 out of 38. Well, that 20 out of 38, like I discussed, comes from the 18 even numbers as well as the 0 and the 00, which is 20 out of 38, plus $5 times your 18 out of 36, which is your odd numbers. And that will equal negative 0.26. So which of these options is best? Bet on odd or don't bet? And why? Well, the best option is not to bet, because the expected value for no bet is 0, which is better than negative 26 cents. Overlapping events. A pollster randomly selects an adult for a survey. Let M denote the events of getting a male, and let R denote the event of getting a Republican. Are events M and R overlapping? Well, they can be. The pollster could select an adult that is a male Republican. So in that case, they could occur at the same time, so the events are overlapping. Assume that boys and girls are equally likely and that the gender of a child is independent of the gender of any brothers or sisters. If a couple already has 3 girls, find the probability of getting a girl when their 4th baby is born. Since the births are independent, then the probability of a 4th child as a girl is still 1 out of 2, which is 50%, or 0.5. So the 50 songs on a smartphone consist of 15 that are rock, 20 that are jazz, and 15 that are country. The selections are played randomly and can be repeated. What is the probability of each of the following events? Remember, we have 50 songs here. That's our total. So since the selections can be repeated, the probabilities of each type remain the same for each selection. So in the case of rock, we had 15 out of the total of 50 equals 3 out of 10. And then for jazz, we had 20 jazz songs out of a total of 50 equals 2/5. And for country, there are 15 out of 50 equals 3/10. And you should reduce. The first 2 selections are both rock. Well, that would be the probability of a rock song times the probability of a rock song, which is 3/10 times 3/10, which gets you 0.09. The first 3 selections are all jazz. Well, that's the probability of a jazz times the probability of a jazz times the probability of a jazz. So 2/5 times 2/5 times 2/5 equals 0.064. The first selection is jazz and the second is country. Well, that's the probability of jazz times the probability of country, which is 2/5 times 3/10, which equals 0.12. The second selection is the same song as the first. Well, there are 50 equally likely songs available for each selection. No matter which song is played first, the probability that the next one is the same is 1 out of 50, which equals 0.02. So in a clinical trial of an allergy medication, 110 people are treated with the medication and 101 other people are given a placebo. A control group consists of 79 people who are given neither the medication nor the placebo. The number of people in each group who showed improvement appears in the table. So we can see here the improvement, no improvement. Here's our allergy drug, here's the placebo, the control, and our totals. What is the probability that a randomly selected person in the study was given either the drug or the placebo? Well, the probability of drug or placebo equals 110, because that's our total in the drug and the placebo of 101 out of the total of 290, which equals 211 out of 290, which is 0.728. What is the probability that a randomly selected person either improved or did not improve? Well, improved, our total was 137, and not improved is 153 out of our total of 290. Well, when we add those, that is our total, so it's 290 out of 290, which equals 1. What is the probability that a randomly selected person either was given the drug or improved? We can work this one in two ways. We can do the probability of the drug or improved. Well, the probability of the drug is 60 plus 50 plus improved. We've already had this one, so we then do the 45 and the 32. Gets us a total of 187 out of 290, which equals 0.645. Or we can also do the probability of the drug, which is this, plus the probability of improved, and then subtract out the one that overlaps, minus the drug and improved. So if we do the probability of improved, then we get 110 plus, the probability of the drug is 110. The probability improved is the 137 minus the drug and improved, which is 60. And we still get the same total. So you can add, make sure you only add them once each time. So the 60, the 50, the 45, and the 32. Or you can do this total plus this total minus the overlap. Either way works. You still get the same answer. What is the probability that a randomly selected person was given the drug and improved? Well, the drug and improved is that 60 out of the total of 290, which equals 0.21. Now we're looking at correlation. So for each pair, state whether you believe that there's a correlation between the two variables. If you believe there is a correlation, state whether it is positive or negative, and explain your reasoning. The weights of taxicab passengers and the costs of trips. Well, there's no correlation here because the weight of the taxicab passengers do not affect the cost of the taxicab ride, and vice versa. The pulse rates in beats per minute and SAT scores of adults. Well, these are not correlated because an individual's pulse rate do not affect their score on the SAT and vice versa. The weights of gasoline-powered cars and the distances they can travel on a gallon of gas. Well, these variables will have a negative correlation because as the weight of a car goes up, the distance it can travel on a gallon of gas goes down. So we're looking at the graph. Which point is an outlier? Remember, an outlier is one that's not with the group. So this would be an outlier right here, that point. And ignoring the outlier, estimate or compute the correlation coefficient for the remaining points. Well, the point is 0.4 and 1.0 because we can go up this way. Since it is an outlier, it lies far from the rest of the data points. Without the outlier, there is no linear relationship between the variables, so the correlation is 0. Because if we take out the outlier, the rest of the group there is just a group. It's not linear. Remember, it has to look like a line. So our correlation would be 0. Now, if we include the outlier up here, and we can kind of see then that there's kind of a linear thing going, how does it affect the correlation coefficient? Estimate or compute the correlation coefficient for the complete data set. So with the outlier included, there is a negative correlation. The actual value would be r equal to negative 0.58, but we're looking at that it was going to be negative.